diagram?
Oh, no? What?
Hey,
Okay. It's obvious. I'm gonna warm up to it. Okay. So graphing a line. It's a graph. It's a coordinate plane. And you have the x-axis and you have the y-axis. So let me warm you up to that first. Okay. So what we're going to be doing, we're going to be looking at the pictures of mathematics. What? I'm not talking about pie charts, right? But what if I said what we're getting ready to do is basically a picture of a mathematical relationship? Okay? And maybe something comes to mind from Delta Math, like, the tape diagrams, right? But let me give you a quick refresher. Okay, suppose I said we have x, or let's say 2x plus 1 equals 11. Okay? How many answers does that have? How many answers does that have?
Is it 1?
That's my question. You said 2. You said, is it 1? Why'd you say 1, Cole?
Is that not within 4?
What is it?
5?
Excellent. It's 5. Is that it? Is there any other number that can be multiplied by 2, and then you add 1 and you get 11? Don't think this is harder than it is.
No.
No, there is not. That has how many answers?
1.
1. 1 and only 1. Agree?
Right.
Okay. So the answer, the solution, we're going to say is x equals 5. So a solution, again, is something that makes an equation true. It's the answer. That's what we've called it for so many years. But how would we check it? We could plug it in and we could say, okay, 2 times 5 plus 1. Does that equal 11? We'll say that's 10 plus 1. 11 equals 11. Yes, it does. One answer, right? That's nothing new. Maybe I'm giving you more verbiage or terminology. Like, yes, use the word solution. It means it makes the equation true, or it satisfies the equation. When you guys are satisfied, how do you feel?
Good.
Good, happy. So a true statement is a happy one, a satisfied one, so to speak. Okay, so that's not less than 85, though. But I'm drawing on your understanding of the fact that, hey, x equals 5 is the answer to that. Now, suppose I changed it just a little. Suppose I said 2x plus 1 equals y. And I'm going to ask the same question I started with here. How many answers does this have? Carson, can you think of one? Could you use the above example to give me one solution? KK?
What?
Could you give me one solution to 2x plus 1 equals y? Maybe looking at the top example and connecting those dots.
It can be like we down.
Right? Not anything. There's some conditions. Jeremiah?
Is it like every odd number above like 3?
Is well, how many? Let me frame this a little bit more for you. How many variables are there?
2.
When you give me an answer, do you have to tell me what x is and what y is?
Yep.
Yeah.
So it's 2.
What's 2?
How many solutions are there? There's a solution for x and there's a solution for y.
Do they have to match up? So I can just plug in any number for x and any number for y and it'll be a solution?
No.
Why not, Maddie?
Because y is the answer, so whatever you add, multiply, you have to multiply 2 by something plus 1, and then that equals y.
Oh, so y, whatever you get for y, depends on what was put in for x. Outstanding, I think. Can anybody use what Maddie just said to find an answer? If I restate what she said, whatever you get for y depends on what you plugged in for x and multiplied by 2 and added 1.
Any answer?
Yeah, any answer that is a solution.
X is 8 and y is 17.
Oops, not 5. X is 8, y is 17. All right, KK, what'd you do to get that?
2 times 8 plus 1.
2 times 8 plus 1. Oh, okay. So you see, did she follow Maddie's direction? She plugged in a number x. She decided 17 would be the matching output, if I call it something. Okay. All right. KK found the answer, or are we not done?
Yeah, but plug the number.
What do you want to do next, Jeffrey?
Plug in x and something, or 8 and something into the actual problem.
Plug in what?
8 and
Oh, you want me to show you that KK's right?
Yeah.
Sure, we'll try that. 2 times 8 plus 1 equals 17. 16 plus 1, yeah, 17. 17, it's a solution. You see, you guys are thinking really hard, like, wow, there's 2 letters here. I'm not sure I'm getting the picture. And I use that on purpose, that word. You see, what we're going to do is generate a picture based on the solutions. There's an S there. I'm not a snake. I'm not from Slytherin. I said solutions. How's that different? This had one answer, and we were done. 2x plus 1 equals y. It doesn't have just one answer. Or 2, or 3, or 700,000. It has an infinite number of answers. You see, when you change to a format like this, this is a relationship between 2 quantities, each of which can change. One change will affect how the other changes. So it sounds kind of complicated when I say it that way. I'm realizing that now. But what if we just continue doing a little bit of what Cadence did here? Can anybody tell me what the solution would be here if I bring down x equals 5? Don't we know that y would be 11 when x is 5? Or what about when x equals 0? That can be an easy one to do, right? When x is 0, what is y?
1.
Okay, let's do one more. Let's do a negative, like negative 2. Y equals 2 times negative 2 is negative 4, plus 1 is negative 3. Now, do you think it's a coincidence that I chose the letters x and y while I've given you this? Okay, these are not just random letters. They are associated with coordinate, there's 2 of them, pairs. A coordinate plane is the surface on which we will graph this. So, graphing is a verb now. Okay, maybe it's already been for you. But before we get over to this one, what I'm going to do, I'm just going to kind of draw a little sketch of a coordinate plane here, and you should as well on your paper somewhere. Okay, and I know it doesn't have the boxes that you can count. That's okay. We're going to move past that eventually, but we'll do that on the other examples. But what I need you to see is that all of these satisfy this equation. So what if I was to start plotting these bad boys? For example, 8, 17, 5, 11, 0, 1, negative 2, negative 3. You see, all of those are associated. Those are the x and the y coordinates. So they represent what on the coordinate plane?
X.
Points. They represent physical points. So if we do that, 8, 17, and again, I'm going to have to just estimate here, 5, 11, 0, 1, and negative 2, negative 3. All right, now my scale is pretty much off. You see, there's a certain attribute of this that should be true, and my estimating is just a little bit off, but I think I can work it out. You see, if we call it a line, then it's going to have what quality? supposed to be straight. And it will be when you graph it on the other ones. Now, what just happened? Why did I connect the dots? What is all this? First off, why do you call this a line?
So it's never ending.
It's never ending. Wait, what gave that away? The arrows? Okay, so a line by definition is straight and continues forever in both directions. So you never have to say the words straight line together. That's an oxymoron. Okay? That's like... No, I better not say that. So, a dumb imbecile. Those words mean the same thing. Stop pointing the finger. All right, so what are we doing? We're taking an equation and we're creating a picture of that relationship. Now, how many points do you see here? Trick question. Do you see 4 or do you see more? Huh?
4.
You see 4? Why did I connect them? To show. Oh, that's loud. What do you mean? It's going up that way. It's going down that way. Why did I connect the dots? Not a metaphor, actually, literally asking you. Why did I connect the dots?
To show that it's straight.
I guess that does help you see that it is straight. Is there a solution in between these two? What could I do to see, Jeffrey, to see if there's a solution between these 2 points? Is there an x value between 5 and 8, Carson? 6 and 7? So what if I chose 6? How would I see what matches with x equals 6? Well, because it's part of the line y equals 2x plus 1, I'm going to plug 6 in for x. 2 times 6 is 12 plus 1. That's 13. 6, 13 would be on the graph right there. Now, you're just going to you're having to trust me because I'm saying, oh, it's on the line. What if it wasn't? What if your line is off? Well, mathematically, I know that it's not. But if you need proof, allow me to go to one of my favorite websites. And show you y equals 2x plus 1. And then, why don't I plot the point 6, 13? Let's see if it's on there. Boom. There it is. You see, what we're working on in Lesson 85, how to generate the graph of a line. Okay? So all of this conversation has been, what is a line on a coordinate plane? It's a collection of all the points, also known as solutions, that satisfy an equation. All of the matching x's and y's. Now, why? Let me ask you one final question before we get to some more examples here. If I asked you, is 10, 23 on the graph? What would you do to answer that question? You guys are good at being silent whenever I allow you think time. What would you do, though, to answer? Is 1023 on the graph? Peyton? You look like you want to say something. You said, yes, it is? How do you know? Don't know? It's just a hunch? Anybody else have a hunch or something more? Don't think so? Yes, no, yes crowd, and a no crowd. 10, 23. How would I check? Oh, there's something we can do. I can check. I'm going to plug it 10 in for x and y in for 23 for y. And I'm going to see if it satisfies, aka it makes the equation happy. True is happy. True. Okay. So 2 times 10 plus 1. That's 20 plus 1 or 21. And is that equal to 23?
No.
No. Okay. Not on the graph. So we had to walk through something to be able to say, okay, that's not on the graph because it doesn't satisfy the equation. So there's a lot to this, by the way. And you're going to come back to this again next year, for real. Okay, so I'm going to try not to go too deep with it this year with you. But you're going to be graphing equations for the rest of your school math career, okay? This one is just the simplest. So let's take a look at how you're going to be working on it for algebra half. Suppose I'm going to give you a few different ones to work with here. Y equals negative 2x plus, 3. Y, maybe we'll just do 4, okay? 1/2 x plus 1. Okay, so I've given you 4 equations that maybe now you're going to come to understand that represents 4 different, how do they show up on the coordinate plane? We call that shape, we call it a line, that figure. So I've given you 4 lines to graph. I haven't told you about how some of the specifics work. What's going on here, okay? What I have told you, though, is why it makes a line. You just plot all the points. Now, could we ever plot all the points? No, because there's an infinite number. Let me take just a step back. I didn't tell you why it makes a line just yet. I haven't talked about that. I can't talk about that yet. All I've said, though, is that, hey, x's and y's are matched pairs. They create a picture, and after we start matching some pairs up, we see that picture is a line. So what we're going to do for lesson 85, we're going to make a table. And I just want you to do 3 points. We're going to pick 3 numbers for x, we're going to plug them in, and we're going to see what the matching output is for y. So here's my advice. Choose a negative, 0, and a positive. And you could do those for almost all of them. Some of them will give you more trouble, though. So we're going to choose a negative, 0, and a positive. We're going to do the same thing for this one. So let's walk through. So negative, 1, 0, and 2. So what does that look like? Well, it means I'm going to plug in x equals negative 1, and I'm going to find the matching y value. So negative 1, subtract 3, what would that be? Well, that's 2 negatives. It's going to be negative 4. If I have negative 1 and I take 3 more away, okay, so negative 1, negative 4. Look, that ends up being a point on my graph. Negative 1, negative 4. What happens when I plug in 0? 0 take away 3. What's that? Negative 3. 0, negative 3. And then let's plug in 2. 2 minus 3. Negative 1. 2, negative 1. Now you look and you understand, hey, this is called graphing a line. If my points don't make a line, I did something wrong. So then all we're going to do is draw a straight line through those points. And I did it. I said straight line. I said that we didn't have to do that. But that would be the picture of y equals x minus 3. See, that has a visual relationship or a visual connection to y equals x minus 3. It's the picture of that. Okay? All right. Why don't you guys try y equals 3x minus 1? Got to open up the book here. Just a second. Let's see. So your using these x values, we're going to plug them in and see what the corresponding y value is. Said another way, that means the y value is going to depend on what you plug in for x. All right, so if we plug these in for x as -1, 3 times -1. You see, 3x means 3 times x. So 3 times -1 is -3. Take away one more, that's going to be -4. So I can plot the point -1, -4. Again, hopefully you're seeing the culmination of several skills here. Adding and subtracting integers, evaluating, and plotting points in the coordinate plane. 0, again, that's going to be an easy one that you should also always do. It's kind of an important point there. 3 times 0 is 0, minus 1 is -1. So 0, -1. And then 2, 3 times 2 is 6. Take away 1 is 5. So 2, 5. And by the time you connect those, hopefully it does show itself to be straight. Okay, now for time purposes, we're going to stop there for lesson 85 because I have a couple things to talk to you about for lesson 86. So don't worry about these other two. We'll come back to those on Thursday. We are going to revisit this on Thursday because this is a big topic. Okay, so on the back of this paper or in your notebook, we're just going to jot down a couple things about algebraic phrases. Okay? Everybody got what you need here? Don't worry. We got a lot more practice to do on that. So lesson 86, for these last couple minutes, we're going to talk about algebraic phrases. Okay? Algebraic means, hey, we're starting to mingle numbers and letters. And the letters we call variables are simply placeholders for numbers we may not know at the time. But the purpose of this is to show a relationship between quantities, some of which may not be known. You see, you already did you did that when you did the problem with Mr. Carter, and you came up with the number $20 per foot. So in pricing a job, the fencing contractor may have $20 per foot for whatever the customer desires. They don't know how much the customer's how much footage they're going to want, so that becomes a variable, but the 20 becomes a constant. And there's a relationship there. So that's why we have to know how to work with those things. So first thing I want to ask you, are there some key words that tell you when to add? What are some words that tell you to add? That you use in math class, that aren't just add.
Sum.
Yes!
Average.
Average, that was a complicated one. We're going to come back to that one. Any of these?
Further, subtract, it's difference.
Difference, okay, good. What else? What about less or minus or decrease? Decreased by. Therefore, we can say, for add, we could do plus. We could do increased. Could we also just do more? What about for multiply? Just give me one for multiply. Or two. How about times product? Anything else that tells you guys, hey, this is the point where we want to multiply? Anything else tell you to multiply?
Factor?
Okay. Factor can be multiply or divide. That's a really good one. Quotient for divide, half, third, divided, split. There's a lot of different clue words, okay? And this is not an exhaustive list. That means I didn't give you every single one, but I did give you the main ones. And why do we have to know those? Because we have to translate. Does anybody know what I mean by translate in terms of language?
Makes it understandable.
convert it from one language to another. That's what translators do, especially in school. So we're not going to do that. We're going to translate it from just words to math. 7 more than a number. 7 more than a number means I'm going to add a number and 7. I just chose the letter A. But you could use any letter. You could do X if you wanted. What about 5 less than a number? Let's just hit the hard one before you guys leave. 5 less than a number.
5 less than a number, that means you're going to subtract 5 from whatever.
That means you're going to subtract 5. What was that word you said?
From.
Thank you. You guys might just skip over that hurdle already. 5 less than a number means I'm going to start with the number, and then I'm going to take 5 away. You see, the most common error students make, they put 5 minus b. Jeffrey saw right through it. This is 5 less than a number, so start with a number, take 5 away. Difference of a number and 10, product of 3 and a number. I feel like you guys can get those last 3, but the first 2, make sure you understand those, okay?